So, good morning. In today's episode, I'm going to talk about a very common topic, that is the starting system, which is under the vehicle, electrical, and electronic systems. So, the starting system is, as it is, we're going to start with the definition of the starting system. Then you're going to go to the components of the starting system. Then you go to the construction of the starting system. Then we finish up with what we call the operation of the starting system, of course, by aid of a diagram. So if you can check on my projection of the PowerPoint here, we have something that I would like us to use as an outlay, which is going to show us about the starting system components working on the starting system, just what I talked about and the working principles. So the starting system components itself, before we come into it, we can say the function of the starting system is just to start the car. That is all. And as much as and as big as the component is and as costly as the component is, it is just work. The work of that component is just to start the car, and that is all. Just by pushing on, that's the pinion gear, to mesh with the flywheel gear. And then after it has started the car, that is all. It has already completed its function. That is when we will be able to see the types of the starter motors and how they are groups for small vehicles and for heavy commercial vehicles. So, back to our PowerPoint, the starting system components, as we have already said before, this is a motor like any other motor that rotates your engine in order to allow a spark and fuel injection system to begin the engine's operations under what you call its own power. Typically, the starter is a large electric motor and the starter coil mounted to the bottom, generally one side of the vehicle, transmission bell housing, where it connects to the engine itself. So the starter has gears which mesh with a large flywheel gear on the back side of the engine, which turns the central crankshaft. Because this is a lot of physical weight on friction to overcome, starter motors generally are very powerful. They are high-speed motors and use an ignition coil to run up their power before what you call engaging. So, physically, if you can look at the drawing that is on the board there, it can show you the components for the starter motor. As seen, you can try to enlarge that a bit. So the components are just as shown on the board. So this is what you call the solenoid windings. I hope it's clear. We have the return spring. We have the shift lever. Very, very fast. We have the pivot pin here. On the back side, we have the plunger contact disc. We have the motor field terminal. We have the bypass ignition terminal. We have the brush end plate. And just below it, we have what we call the field brush. We have what we call the brush spring here. Then coming over this side, we have the ground brush, ground bush. We have the field coil. We have the armature, which is a major component. We have the ball shoe, we have the motor, and then we have the overrunning clutch. We're going to talk about the function of the overrunning clutch. We have the drive pinion over this side, and then we will be able to check the drive pen housing and the pivot pinion, as we said before. So over this other side, this drive pinion is where you're going to have what we call the area that is going to provide us with the function of the starter system, because that is the part that is very, very small, but it does a lot of work, and that's what provides the function of the starter. So the components, very, very fast. The battery, we just say briefly, the battery, what does it do? And that is all. So the battery provides a source of power. That is all, nothing else. Provides a source of power for what you call the pinion gear to mesh with the flywheel ring gear, and then it gets back. So this, I'm not going to read all this, but generally just shows that it provides power. Number two, the ignition switch. The ignition switch just from what you can see here, is a component which is just next after the battery, whereby you find that we have this is the earth, negative side of the battery, and then we have what you call, followed by the ignition switch. Okay, then you come over to the other side. So its function is just to act as a switch, or a connector, whereby it allows the driver to distribute the electrical current to where it's needed. So there are generally 5 key switch positions that are used. We always have what we call lock. We also have another one which we call the off position. We have the run position. We have the start position, and we have the accessory. And this one always depends with the type of car that you have. How much the original equipment manufacturer depends with the OEM of that particular car. So the most ignition switches are mounted on the steering column. Some switches are actually 2 separate parts. And with the development of the training of the new technology and everything, you find that these ignition switches are turning up even to a slight press of a button, and then your car has just started. So we have number 3, the neutral safety switch, which opens sometimes, and the starter circuit when the transmission is any gear, but neutral or park on automatic transmissions. So sometimes it cannot allow you to start the vehicle unless your vehicle is on neutral. So this is a purely a safety gadget that has been introduced. So this switch is normally connected to the transmission linkage, and what happens is that, or directly on the transmission system, that's the gearbox. Number 4, we have a starter relay. A starter relay is a device that allows a small amount of electrical current to control the large amount of current that maybe comes from maybe the battery. You know, the battery can produce up to almost 13 volts. But when that comes over to the other side, sometimes it can spoil some components, electrical components. We have the resistors, we have fuses, we have so many electrical components. So it will only allow the right amount of current to pass through to the other parts of the vehicle. Now we have the battery cables. The battery cables must be of the right kind of condition, right material, right width, and so forth, so that it can be able to contain the amount of power that is passed over the other side, which is almost 250 amps plus. So that's some have smaller wire soldered. The terminal switch is used to either operate a small device or to provide an additional ground. So when the smaller cable burns, what happens is that there is a short and current can never be passed through. We have another thing called a starter motor. A starter motor is what we basically found out that is one of the major components of the starting system. And the starter motor itself is a powerful electric motor with a small gear, which is a pinion attached to the end. When activated, the gear is meshed with a larger gear, which is the flywheel ring gear, and then which is attached to the engine, and hence it starts the vehicle. So the starter motor then spins the engine over, so that the piston can draw in a fuel-air mixture, which is then ignited at the CC, which is the combustion chamber. So when the engine starts to spin faster, then the starter motor does the same. And there's a device called an overrunning clutch, which is appendix, which automatically disengages the starter gear pinion from the flywheel ring gear. So basically there is a starter circuit here, and you'll be able to see that it's something that I was almost trying to draw for you here, right? As you follow it from the earth, then you come to the battery, to the negative side of the battery, and then to the other positive side of the battery. It's going to come to the ignition key, then from the ignition key, It's going to come into some starter safety gadgets that we talked about. Then this is the one which is connected to the transmission system. Then it comes over to the solenoid. The solenoid is the part that acts like a switch on the starter motor. So it switches on and off. And then from there, then it's going to be controlled, some control lines there. Of course, with what we call a closed loop system from the ECU. And then now they can be able to turn in the what we call the flywheel. So this is what we call the flywheel ring gear. The flywheel ring gear. So from that, basically, it shows you what we call a slight circuit of a starter motor, in case somebody will ask you about that. Now, lastly, if you're going to be asked about the working principles, how does the starter motor itself work? Just give a brief one paragraph explanation of that by just saying that to make the engine start, I'd like to magnify this a bit so that you can be able to see. So to make the engine work or start, it must be turned at some speed. So that it sucks fuel and air into the combustion chambers and compresses it again. Then, number two, you realize that the powerful electric motor does the turning. Okay? So its shaft carries a small pinion gear, as we have just said, which engages with a large gearing around the rim of the engine flywheel. Number three, in a front engine layout, the starter is mounted on low down near the back of the engine. Number four, the starter needs a heavy electric current, which it draws through thick wires from the battery. That's around 12 to 13 volts. Then no ordinary hand-operated switch could switch it on. It needs a large switch to handle the high current. Then number five, we have what we call the switch has to be turned on and off very quickly to avoid what we call dangerous, damaging sparking. So, a solenoid is used and an arrangement where a small switch turns on an electromagnetic to complete the circuit. Number seven, the starter switch is usually worked by an ignition key, which turns the keyboard and the key beyond the ignition on position to feed the current to the solenoid. Number eight, the ignition switch has a return spring, so that as soon as you release the key, it springs back and turns the starter switch off automatically. Number nine, when the switch feeds current to the solenoid is the one that I talked about, which is the switch. The electromagnetic attracts an iron rod. So the movement of the rod closes to heavy contacts, completing the circuit from the battery to the starter. Number 10, the rod also has a return spring. When the ignition switch stops, feeding current to the solenoid, the contacts open and the starter motor now stops and rests. And now what we call, last but not least, the return springs are needed because their function is that the starter motor must not turn more than it has to turn in order to start the engine. So the reason is partly that the starter uses a lot of electricity, which quickly runs down the battery. And then also, the engine starts and the starter motor stays engaged, so the engine will spin the starter so fast that it may be badly damaged. And now, to talk about almost as you go finishing about the operation of this, the starter motor itself has a device called the Bendix gear, which engages its pinion with the gear ring on the flywheel only while the starter is turning the engine. So it disengages as soon as the engine picks up the speed. And there are two ways by which it does this. So one is what they call the inertia, and two is what they call, that is the pre-engaged. Now, and this one brings us also now next to the types of what we call the types of starter motors. So when you come to the types of starter motors, you realize when you talk about inertia, what is inertia? What do you mean by inertia? Inertia is briefly what you talk about, like it's a kind of drive. It's a kind of drive so that you can be able to see the difference between the two types of starter motors that we have, as much as we have them in heavy and light commercial. So inertial starter motors, they produce an inertial drive. So these are an engagement device used for the starters of most cars, and most of them are called light commercial cars. So I want you to mark this. So if these ones are used for light commercial cars, then it goes without saying that the pre-engaged are going to be used for heavy commercial cars. So after this, what you're going to discover is that the inertia due to the mass of the starter pinion is made use of in the engagement action. And now, number two, when the pinion moves like inwards towards the starter, then to engage with the ring gear on the flywheel, this motor drive is closed as an inward type when the pinion moves away from the starter. It's an inward type of system here that we're talking about. So in all motors, the shaft and the float is limited by what we call ship washers fitted between the end plate faces and shoulders on the shaft. So these are some of the things that are giving you the differences between the inertia and the pre-engaged. And what we're going to talk about on the construction of this type of starter motor is that on the construction of this, the armature shaft is planed and has what we call a short threaded portion at the end. So this is what you say when you talk about the construction. So the drive itself consists of the following things. One, a shrouded cylindrical cylinder. That's what we say about the construction. What is something made of? How does it look like? And that's not just the function, that's the construction. So number two, a light coil spring which is fitted over the slip. There is a coil spring. Okay? Number three, a thick washer which controls the pinion travel. And then number four, we have what we call a sleeve that is internally splined to the armature shaft and also has an internal multi-stud square thread. Number five, the pinion has an internal multi-shaft square thread. 6, a thick spring retainer washer. Those are the way it's constructed. A very strong compression spring. This spring is very, very strong because it's the one that compresses itself. A spring retainer nut and split ring. Okay? So these units are assembled in one in the above given sequence, and the pinion fits over the sleeve and being held in the position by the two kind of washers. So this is how basically how it looks like. And this is how the engagement works, and this is how when there is an engagement and there is a release. There is an engagement and there is a release. Engagement and release. So we have a spring sleeve, we have a control washer, spline sleeve, compression spring, nut, and that is all about the construction of an inertia type of starter motor. So you check on the operation very, very fast. On the operation, we have the engagement. Engagement is the time you will find that the flywheel itself, as you can see, has to engage with the small pinion. So this is a pinion, and they are talking about the engagement. This is a flywheel. So when you talk about the engagement, is when this one moves over to the other side. Just exactly what you've seen over the other side. So to engage the flywheel. And the disengagement is when this one moves back. In other words, you can call it release. So what happens on the engagement side, as I've already pointed over the other side, when the starter switch is switched on, the armature and the sleeve quickly release the high speed of rotation. So due to its natural weight, the weight, that is the weight of rotation, what happens is that that's of the pinion is delayed. So, and this results in it being screwed laterally along the sleeve, compressing the light spring and being stopped by the control washer. Then next, after that, number two, on the engagement, at this point the pinion is meant to engage with the ring gear of the flywheel. So the compression spring absorbs the shock of engagement. So here it's all about release and engagement, release and engagement. So on release, an engine fires, the flywheel speed becomes greater than that of the pinion and the armature. So the pinion is thrown back out of the engagement and the compression spring absorbs the shocks. And that is all. So that is all about the release and what we call the engagement. So some few things to note. One is that the pinion and the sleeve threads must be kept clean, and only the thinnest possible film of thin oil is allowed. Should be used. Two, a dirty or over-lubricated pinion may result of fault engagement. Number three, at a process of faulty engagement may be broken, springs or incorrect out of mesh clearance. Number four, the light spring is used to prevent the pinion being moved into mesh by vibration of the engine when the engine is running. So failure to release may be due to of the following causes. One is the worn flywheel or ring teeth. We're going to talk about this one in the workshop. When we go to the workshop, we'll talk about the trouble diagnosis, the symptoms, causes, and remedies of some of these problems of the starter motor. So I'll be able to jump that and go directly to the braid gauge. And this is where we're going to stop. So the braid gauge starter motor is another type of starter motor. But in this type, this one is used in heavy commercial vehicles. And the inertia is used on light commercial vehicles. So the braid gauge starter motors consist of the following things. One, a motor itself. Two, engagement relay. And three, a meshing drive pinion. 4, the roller type one-way clutch. So this is how it looks like, basically. You look at this, it's a meshing drive, this is a pinion, and then we have the engagement relay here, which some of you call the solenoid switch, and we have a starter motor itself over the other side, the whole thing. So, when we check on that, we have the solenoid switch construction is as follows. What is this thing made of? How does it look like? So the switch is mounted on the starter motor housing, so it has two windings. The pulling and the what you call the holding windings. So it has a large and small plunger and a contact disc. So at the end of the large plunger, there is a yoke which actuates the drive pinion. And then after that, there is a slight diagram here that shows how this one looks like. I can be able to magnify it for you so that you can be able to see it. You can be able to see the plunger. You can be able to see the starter switch, the plunger, the pulling windings, the holding windings. We have the belt terminal, to starter switch, and to the ignition coil at the motor terminal. So all these, you're going to see them when we get to the workshop. But today we are just covering this starter motor in the classroom. So when the ignition switch is switched on, we are talking about the operation as we finish. So the ignition switch is switched to on position or start position. The current flows in both windings of the cylinder. So this creates a magnetic field strong enough to pull in the large plunger, which shifts the overrunning clutch and pinion drive to mesh with the flywheel. Just as simple as that. And you realize that as the large plunger continues to move inwards, it strikes a small plunger and the contact disc is forced against the contacts of the starting motor switch. So this completes the circuit and the motor operates. So when this happens, the pulling windings loses what we call its effect due to the voltage being equal at both ends. So the holding windings continue to hold the plunger in the closed position of a reduced current needed by the solenoid. So we will be able to do these things practically in the workshop, and you'll be able to realize that as I finish out, you'll be able to realize that these things are going to be very, very easy for you. So when the ignition switch is released now to the off position, the current to the solenoid stops. And then what happens is that the spring within the solenoid opens the starting motor circuit and shifts the pinion clutch assembly to the rest position. So the magnetic field in the holding windings is weakened by the changes in the polarity of the pulling windings immediately. This is what we call the ignition switch is released from that position. So the weakening together with the restart spring brings back the pinion via a shift lever and a plunger to disengagement. Before I go further and further and further to many more other types of starter motors that we have, for today we would like to stop there.